Hey guys, welcome back. Today I'm going to walk you through what I've accomplished over the last 2 weeks and where I'm at over a month of developing this game and engine. If you're new, I'm building a programming battle game where you can control thousands of units with code and fight them against enemies and try to learn some programming along the way. I'm building a custom engine in web GPU to run most of the simulation logic on the GPU, and the goal is to be able to run this game efficiently on web. Since my last devlog, I've got a lot closer to a working MVP of my game. I finished most of the base engine and I've started on the gameplay and enemies. The first thing I implemented after the last devlog was the ability to attack other units and do some kind of a simple flash effect and knockback when they were hit. And in Unity this would have taken about 5 to 10 minutes, but with the architecture that I had at the time, I would have needed to send 10,000 units of information to the GPU with the one color value and scale value change, because I had no support for partially updating the data on the GPU. So it was actually a synchronous process where I would send the unit data such as position, scale, color, every frame to the GPU. It would run the simulation there, and then it would give me back the new position, scale, color, which I would give to the unit class that the users can access with their code. So in order to avoid this kind of synchronous data sending and receiving flow, we want the input part of the buffer to be separated and be more like commands rather than data that we're setting directly on the GPU. And then we should have a temporary GPU buffer that lives just on the GPU that handles all the simulation logic and very clearly defined outputs that come out every frame. So we're decoupling the 3 sections of data so that everything is asynchronous. But before I was able to even do that, I had to first refactor how I was handling the whole army simulation. And this took quite a bit of pain and a couple of days to do, but it was definitely worthwhile refactor. The next big refactor and update I did was actually how the user programming affects the little units. In my old system, the user code would talk directly to the Boyd system in the engine, and it would control the Boyds on the GPU. However, that won't actually be possible in the way I'm going to set up the system, as I'll be putting the user code on one thread here and the engine will be running on a different thread. This is mainly so that when the user writes a while true infinite loop, as I expect they will, we can prevent the whole browser from getting taken down. It also makes sense from a performance point of view because you can't expect new programmers to write super efficient code. Even better, this will also prevent cheating, as they won't be able to reach across into the scene and, for example, just set the Boyd position to teleport them across. Everything can be handled via messages, so you can make it really secure, and there's no way to affect the data within the thread unless you allow it to be via messages. After I did all of this housekeeping refactoring work, I was ready for actually starting the gameplay. The first thing I handled was units being able to attack each other, added a bit of knockback force and handled their death and cleanup on the GPU. Also, I had to create an efficient way for them to attack each other since there's thousands of units. So what I did was I created a grid system, and every frame a unit will hash itself within the grid so it will know what grid square it's at. Then you can look up what units are in your neighboring cells, and then you can only do the attack comparison against them. After I did the attacking, I created an abstraction layer that allows these units to be either enemies or friendlies, and then I finally had them all come in and start fighting each other. So after nearly a month, I'm finally starting to see some action. So this was a really happy moment for me. Now, the really big question was, how are players actually going to interact with the game? Now, coding 1,000 lines of logic for 10,000 units in one big script is really boring and a very hard way to play the game. However, I thought of a couple of different approaches we can do to improve the game feel. First idea was an input-based approach where you can code the actual inputs like mouse click, WASD, and link them to pieces of code. So for example, I would press C, they'll circle around the unit, and press click and they will go there. But quickly quickly found out that you will run out of input combinations very quickly and you have to remember key maps. And I'm not making a NeoVim simulator, so I'm gonna avoid that approach. The second approach was where you can create these cards and you can put very functional pieces of code within them and say like 10 units. So you can declare like 3 archers, 5 soldiers, 2 giants. That gets given to you in a squad object and then you can control them. You have a very specific squad that has a very simple purpose. It's easy to think about, and then you have these little cards that you can drag onto the map and the units will spawn there and then they'll do whatever they were programmed to do. And the third approach was a real-time terminal where you can place units directly on the map and then you can box select them and then a little terminal will pop up and then you can type your code, and when the terminal comes up, the whole game kind of slows down and then it feels like you're a hacker or a commander kind of moving stuff around. So at the time I thought squad based would be the best, so I set up the squad UI in React and had the code save over multiple sessions and tried playing with it. However, I noticed very quickly that even this is a little boring. You still have to do a bunch of planning and thinking before you can play the game, but I felt like I was getting closer towards some kind of real-time gameplay with programming, rather than the programming feeling like it was just stuck on at the very end. In terms of what the actual game is, it's going to be an arena-based game where you fight a specifically designed enemy and level. Each level will have its own unique twist that will make you think a little algorithmically, but not forcing you to think algorithmically. I think this is a really simple way for me to get a MVP of the game and start giving it to people, because I think the hardest part is really making the programming fun, and then I can create any game mode I want after that. So I'm gonna go with the simplest arena-based combat game idea first. To get closer to this, I started on the first big boss, this rock throwing guy. It took me a little while to get everything sorted and get this guy working. First needed to do collision detection between the rock and the units. And since the units exist purely on the GPU, I have to return collision hits from the GPU back to the CPU efficiently. And after that, I had this guy who was able to demolish my hundreds of units. There's still a bit of work to do. I still need to get the boss moving around and actually chasing you, deploying little minions to follow you around, and do all the game loop stuff, but it's all coming. I just wanted to make this update since it's been 2 weeks. But that's 1 month of progress. Also, I really want to say thank you to the 10 subscribers that I have now. I didn't even think I was going to get that, so thank you very much. Really appreciate it. Love to hear any feedback that you have on the gameplay. I'm going to start putting it up online as well so people can just start playing with it and messing with it. I'm having a lot of fun making it, and I'll see you guys in the next devlog. Catch you later.